Delete columns to make sorted tree. So we'll be solving this problem in this video. You are given an array of n strings all of same length, right? We may choose any deletion indices and we delete all the characters in those indices for each string. It is same as the previous two problems, but let us see what is the difference between these three. For example, if we have strings is equal to a, b, c, d, e, f, u, v, w, x, y, z, and deletion indices 0 to 3, it's the same thing, right? Then the final strings become array becomes bef and vyz. Suppose we choose a set of indices also such that after relations the final array has every string right in lexicographic order. If you see strings of 0 0, nothing but in the first string first character should be lesser than or equal to the second character and the third and so on, right? They didn't said that if you see after the deletions in the first example, after the deletions it is bc and az will come before bc, but if you see it is not in the lexicographical order. The strings, the string array strings is not asked to be in lexicographical order. We are asked so that every string is in lexicographical order and we need the minimum possible value of answer dot length. I'll tell you what it is. After deleting column 0, 1 and 4, the final array is strings. You see, this minimum possible value of answer dot length is nothing but how many indices we need to delete. That's what they are asking for. So E, D, C, B, A, if we delete less than 4 columns, that only row will not be in lexicographically sorted. So GHI, yes, it is in lexicographical order. DEF, it is in lexicographical order. ABC is in lexicographical order. But we are not asked the strings to be in lexicographical order. Every string, the characters in the string, every character need to be in lexicographical order, not the strings. Let's take the first example and understand BABCA, right? BABCA. BABCA. Just take this array, this string. Now, I need this to be in lexicographical order. Now, if I just take A, B, and then C, this will be in lexicographical order, right? A, B, C, and I'll remove B and A, but it is not like that. If we are removing this one and this one, all the strings after this, all the columns, right? All the strings with the same column, right? So there will be some string here. In that string also I need to remove column 0. Here also I need to remove the last column, right? That's what the problem is stating about. So we need to delete columns as minimum as possible and make all strings lexicographically sorted, right? All strings should be lexicographically sorted. That's what the question states. BABCA, right? Now what if I just take B, B and then C? We are asked to have strings of 0 0 is less than or equal to strings of 0 1. If you see here is equal to is nothing but the same character, right? That's what they have stated. Now how can I achieve this, right? How can I achieve this? Let me tell you. B and then B and then C. What if I just give the instances 0, 1, 2, 3, 4? Now, I need a sequence where the characters are increasing. I'll tell you how it can be achieved, right? Let us just take one everywhere. I'll tell you why I'm taking one everywhere, right? I'm taking one, one, one. From this string, I'm saying that ending at this index, I can get a longest increasing subsequence. For now, only one. This string alone is the longest increasing subsequence. That's the first thought I have, right? Let us see whether I can get any longest increasing subsequence. That's just a longest increasing subsequence problem. I'll tell you how I can implement it. B, right? Let's just give two pointers for this. I'm going to give I and then J. So J will be starting with 0 and going till less than I. So I will be here and J will be here. Now, if you see, I will compare it like this. Strings, I'll compare it as string of j. Is it lesser than or equal to string of I? If so, what I'll do? Let me just name it as dp. I'll just name it as dp. I say it as dp of I will be maximum of dp of I, comma dp of j plus 1. That's the simple thing in longest increasing subsequence. I'll tell you why. So if I'm just assuming, like if I have a b here, I can get bb, right? Now, what is this dp of I? dp of I is nothing but the longest increasing subsequence, the longest increasing subsequence ending at index I. That's it, right? So I think you are clear for now. Let us go with next I. I'll just increment I. Why? Because this j will go here, and as I said, j will go less than I itself. Now I is at point 2, I is at index 2, and j is at starting from here again. Now compare again. Is b less than or equal to b? Yes, this condition is satisfied. So dp of I is nothing but this one. dp of 2 is equal to max of dp of 2 is 1. 1 comma dp of j is 1 plus 1 is 2. The maximum of 1 comma 2 is 2. So what I'll do, I'll just change it to 2. That's it, right? So I'm just changing it to 2. Now let us go again, increment our j pointer. Let's increment our j pointer. If I increment the j pointer, here it is. It will go to index 1. Now, dp of strings of j is less than or equal to string of I. Is it so? A is less than or equal to b? Yes, A is lesser than b. So, dp of I, nothing but this one, is equal to max of dp of I is 2. dp of j is 1. 1 plus 1 is 1 plus 1 is 2. Max of 2 comma 2 is still 2. Now the I pointer will be incremented to 3. Now the j will be starting from 0 again. Now b is less than or equal to c. So here it will be changed to 2. Right? I think you have got it at this point. Now I am incrementing my j pointer here to a. Now string of j is less than or equal to string of I, but 1 plus 1 is still 2, right? String of j, dp of j plus 1 is 2, and dp of I is at index 3. It is just 2. 2 comma 2. Maximum of 2 comma 2 is still 2. Now I'll just increment the j pointer to here, index 2. Now b is less than or is equal to c. Yes, it is true. Now dp of I, here 2, dp of I is 2, dp of j is 2 plus 1 is 3, 2 comma 3, the maximum is 3, so I'll just change it to 3. Okay, now let's go and increment our I pointer to 4. I pointer is incremented to 4. Now the j pointer goes to b at index 0. Is b less than a? No. Is a less than or is equal to a? Yes. So it will just change to 2. I think you have got it, but if you have any doubts, please let me know. I think I'm going fast, right? Now, is this j pointer will go to the next point. Now, b is less than or equal to a. No. C is less than or equal to a. No. J goes to I and it breaks the loop, and also I will go out of bounds. Now, if you see, I am saying that here I got 3. I'll tell you what it means. The longest increasing subsequence I can get is 3. But wait a second. We are not asked for only one string. If you carefully observe, let me write the code. What the code I got is for I is equal to 0, I is less than. The number of columns I have is m. I plus plus. M is the number of columns. For j is equal to 0, j is less than I, j plus plus. What I did is, if string of j is less than or equal to string of I. But I will not write the code like this. I'll not write the code like this. I'll just write, I'll tell you how I would write. dp of I is equal to max of dp of I, comma, dp of j plus 1. Now, we are not asked for just one string. We are asked for all the strings, right? We also need to be careful about that. So, let's just remove all these things so that we can understand the actual db here. Now let us take the second string bbazb, bbazb, right? Now let me take bbazb, bbazb. Now what I'll do, I'll just go with the same approach. I is equal to 0 and j is also equal to 0, but no use. I will be going to 1 and then j is 0. Now I will check, is b is less than or equal to a? No. I'll just increment my I pointer and the j pointer is here. B is less than or equal to b? Yes. It will also check. I also need to check the same thing here. Is b less than or equal to a? No. So no updation of all this. Wait, I need to change this, right? 1 1 1. Now I am checking every index. If you see, now j is changed to 1. Is a less than or is equal to b? A is less than or equal to b? Yes. B is less than or equal to a? No. I will be changed to 3. Now the j will be starting from 0 again. Is b is less than or equal to c? Yes. Now b is less than or equal to z? Yes. So dp of j plus 1 comma dp of I. What is the biggest? 1 plus 1 is 2. 1 comma 2 maximum is 2. So 2 will be applied to dp of I. J will be moving to the point A. Is a less than or equal to c? Yes. B is less than or equal to z? Yes. So here also 1 plus 1 is 2, but 2 comma 2 is maximum is 2, so no need to change or update. Now j is going to the next point, point 2. Now b is less than or equal to c, a is less than or equal to z. Both the conditions are true, but 1 plus 1 is still 2, so no need to update it. Now I goes to point 4 or index 4. J starts from 0 again. Is b less than or equal to a? Stop there itself. If it is not satisfied, stop there itself. Then go to the next index j. J is equal to 1. Is A less than or equal to A? Yes. B is less than or equal to B? Yes. So 1 plus 1 is 2. 1 comma 2, the maximum is 2. So I'll update it like this. Now J is going to the next index 2. B is less than or equal to A? No. Skip. C is less than or equal to A? No. Skip. It will go out of bounds, and this I will also go out of bounds. But here if you see, the maximum I got, max C I got is 2. That means there will be two indices which will be longest increasing subsequence. The remaining three I need to delete. How do I get the answer? I get the answer by number of columns. How many number of columns I have? M minus maxi. That's how I get. Now I need to write one thing here. One thing, right? So let me write that one thing. Let me write the for loop which check every row. I'll check every row. For int k is equal to 0, number of rows I have is n, k plus plus. I'll just check. I'll just check if strings of the row is k and the column, j, right, is it greater than strings of k I? If so, is valid. Is valid is true before going and checking every row. Now if the first character is greater for anything, then any string is valid will become false and will just break there itself. After that, I'll update if it is valid. If it is valid, then I'll just make dp of I is equal to max of dp of I comma dp of j plus 1. Now the maxi is updated here itself. Maxi is equal to maximum of maxi comma dp of I. That's how we solve this problem, and at the last we'll just return number of columns is m minus maxi. Thanks for watching this video. I have given the code link in the description. Go and check it. Thanks again. Please do like, share and subscribe to my channel. But let me tell you one thing. Here I am updating the TP, and after the for loop I will update the maxi. Why? Because the I pointer is here and the j pointer is here, right? So only if it is valid, then only for this j I'll update the maxi after the j loop, right? That's how you solve this problem. And if you have any doubts, please let me know in the comment section. Thanks for watching this video again.